So, let's see, are we actually live? Let's see how YouTube is doing. Okay, we're live on YouTube. Let's see, tweets. Yeah, okay, so we are live on both Twitch and YouTube. So let's get started. Now we are going to work with pathfinding and units and stuff with our colony sim, but I think I'd rather make some, maybe have actually something that moves inside the level. So for the first 5 minutes, we're going to just, create some sort of a character. Okay, so hold on ask any questions if you want to. I'm just going to create a base sprite so I have something to move around, basically. I'm not going to worry about making it looking too good. I'm just going to make a naked dude, and for the most part he's not going to even look that nice. Maybe give it a little bit of different shading there. Okay. I'm basing the design off of Broforce. Obviously, I'm not doing that great of a job. And I'm going to drop this one. Yeah, I'm just going to give him a basic outline and then later on come on back and fix it. So, something like this, I guess. We can give him some legs to walk on. Something like that, and let's close it so we can start programming. Maybe do something like that. Okay, maybe draw a line for where his hand is going to be, and then I'm just going to use fill. And actually, you know what, let's do slightly more white as a highlight for those arms. Yeah, probably it's going to look too bad anyway. Yeah, kind of looks ugly. But here's our naked dude. Okay, then we are going to add later, it's logic, and I think I'm going to have to do the outtrim like that. Yeah, sorry, I can't really watch it. If it's really ugly, I can't really be watching that all the time. Maybe give him an outline like this. Oops, that kind of looks like. Anyway, say something like that. And that's going to be our astronaut, our naked astronaut. So let's export this. We are on the same file as our base sprites where we have for our base, and I'm just going to add this unit 1. Okay, export then. Right onto Unity. We're going to have the art down here, and we can switch this into a sprite. Okay, then let's get out of play mode first of all, and we're going to add this guy into our game. Sprite renderer, and add this here. Now he's kind of small, so I'm going to switch the pixel per unit ratio to 12, and then we're going to have to do the same thing we did with our node instances, and which means I'm just going to parent it below. Let's call this sprite. Let's call this unit, and let's rotate this at 25 degrees by 45. Okay, also, what do we have so far? Well, we have our base set up, and we can go up and down floors, and so on and so on. Okay, we are still very early on, but we are, I think we are about 5 to 6, or is it 5? I think it's 5 hours or 4 hours in to all of this, but we've seen a few things, and we're going very slowly. Keep that in mind. Okay, so this guy is going to be point, and okay, this will do. So this will be our guy that we're going to be moving. We're going to be using A star, which of course we're going to also have 3D A star with advanced logic and multiple directions of entry to get inside a point. So let's name this Pathfinder. Now, especially A star pathfinding, we have seen it. I don't even know how many times we wrote our Pathfinder. Okay, but I'm pretty much using it in almost any series that isn't a third-person shooter. So it's something we've seen before. Let me see that. Yeah. Visual Studio kind of misbehaves right now, but we'll fix it. Let's create another script which is going to be called Pathfinder. Okay, the Pathfinder master is going to be from mono behavior. This will be just a simple class. Okay, let me open up my other scripts where there's no really a need to do this from scratch again. So let me find my previous scripts we were using, and that will be Pathfinder. Okay, let's move this aside and let's bring this in, and I think we're going to need the block as well. Okay. Okay, so before we even start with this, let's go on to our node and add the variables that we're going to need for the Pathfinder. And of course, that's always public float, the heuristics cost, then the G cost, and the F cost. However, I think we have turned this into floats, because on the colony sim we weren't using integers, we were using the actual world. Actually, yeah, okay, it's not really that big of a problem. We can still work with this. So on the F cost, we always return the G cost plus your heuristics cost. Then we need the parent node. And for now, I think this will do. So let's go on to our Pathfinder. Now, because before we go to the Pathfinder, let's go to Pathfinder master. And let's start, let's add our logic for multi-threading. Okay, we're going to need the namespace for threading. We are going to need a delegate for the callback, which is going to be returning you a list of nodes for the path, and we don't have a unit yet. Let's just return the path, but we kind of want to know which unit actually started the, actually had the callback request. Now, we can add this. Well, okay, let's do a list, a list of the Pathfinder of to-do jobs. and a list for the Pathfinder for current jobs. Okay, let's have an integer for the maximum jobs we're going to allow. Let's start with 3. And I think this should do. So, let's see, we can make this into a singleton. I think we didn't really need it that much. Let's go add a few things on the Pathfinder for now, which of course first is going to be the constructor. Well, first we need to know the start block and the target block. Okay, and we need to have a volatile bool when the job is done. What is a volatile bool? Is basically whenever you are accessing this bool, gets you, no matter which threads are actually running it or affect this job, okay, this variable, it's guaranteed that you're going to get the most latest value this job has. It's something you see specific in multi-threading, to be honest. So we are going to need the generic namespace as well. Okay, then we are going to need a list of nodes for the path. Okay, and I see a few things that we do not really care for this case. So let me see. Okay, I think these two should do. And let's do the constructor then, Pathfinder. And you know what? Let's also pass the grid manager to this, just so that we can reuse it for different things. So grid manager, node. Okay, let's use the start node, target node, grid manager, and let's make a placeholder and also rename this. Let's make a placeholder script that is just going to be your manager. Let's create a new folder and let's call this yeah, okay. And let's just do this inside managers, whatever. Grid unit or grid object, I guess. I think everything that can be on top of the grid could move. So I guess grid object wouldn't be that far-fetched. Anyway, let's use that grid object. Now the namespace. Let's delete all of that. And I'm just going to leave it like this. Then on your Pathfinder, let's say grid object, target object, or target moving object, or just unit. Let's call it unit. Okay, then grid object, unit. So this dot start node, this dot target node, this dot unit, grid equals grid manager. Okay, now when we actually call to find the path, so when we do public void find path, is where the Pathfinder is actually going to be happening. We are going to get a list of nodes, find path actual. Okay, and let's return null for now. So that will be your path equals find path actual. And after that process is done, we're going to be saying job is done. We need a method to actually notify you that this is complete. So we also need to store the callback for this. Pathfinder master path complete callback. And let's collapse this, okay. Just so that we can see. Awesome, and let's also store the callback here. So that means this dot callback equals callback. If you have any questions or anything, okay, feel free to ask them. I'm going to be simply going fast with this because I already have a lot of videos that we can watch and we have done this. However, feel free to ask any questions, but I don't think you're going to have any. So let's add a notify, which is going to be executing our callback if it's not null. And that callback needs to have a few things. Now that we have a unit for grid object, let's also pass that. So path and unit, and that is your callback. Okay, so now that we have all of this, before we go and add the logic inside path actual, let's finish with the Pathfinder master. So we need a method that is going to be requesting pathfind, okay, from or start, target, and who actually called it. We could get the grid object. We could do this actually, or current node. However, let's leave it for now. And then this is going to be creating a new Pathfinder job. So path job, new Pathfinder, and we need the start, the target, the unit, the grid manager, which we are going to be passing this from the grid manager either way. So I guess we could do this. Okay, let's pass the grid manager as well here. And we also need to know the callback. So grid manager and callback. And we're going to be getting that path job, and we're going to be adding it on the to-do jobs dot add path job. Okay. Okay. Awesome. So inside update, then we're going to start with an integer I equals 0, and while I is lower than the current jobs dot count, if current jobs I dot job done, so if the job is done, then simply say current jobs I dot notify complete and remove at I. Okay, that's if you want to do it as a while loop. Else I plus plus. Okay. Then if to do jobs dot count is greater than 0 and current jobs dot count is less than the maximum jobs, we have then Pathfinder job will be your first in the list, then remove at 0 index, then add that back to your current jobs. Okay, then we're going to start a new thread, job thread, which we're going to add job.findPath. Okay, the method for finding the path. Then all we have to do is say job thread.start. Now in C# we don't actually have to finish. We don't actually have to call or, you know, remove, manually kill the threads. We don't have to do that. But I think in Unity, for whatever reason, in the editor, it doesn't always work this way. So it doesn't always kill those threads. So we can go and say for on disable current jobs dot count. Yeah, I think that will allow us to find. Yeah, okay. So I'm just going to say current jobs dot notify complete. Okay, when you disable, which means whenever you are closing the game in the editor, it's going to say. It's going to notify complete, so that means it's going to stop the callback. Okay, so that's for the Pathfinder master. I guess we can make this into a singleton, but we'll see if we need it, so let's remove that. So let's get to the meat of it, which is the Pathfinder, the actual Pathfinder. So, notify complete, find path actual. Now, I'm sure you've seen this before. We're going to start with a list of node result. Going to return as that. Then we have a list of open set. And because we simply want to be checking if they are inside, if these objects, in this case, these are the nodes, if they are inside. Look, if you want to, for me to say stuff in the YouTube, yeah, just say, write it in English and not in Greek. Yeah, I do speak Greek, but everyone should be able to understand. So, close set. Okay, because we're going to simply find fast if the node belongs inside the closed set. Searching inside the hash set is faster than searching inside the list. Okay, so for open set dot count, if open set I dot fcost is lower than the current block, which we obviously forgot to, yeah, we kind of skipped a few things, damn it. That's what we get when you stop to talk in the chat. So on the open set, we're going to add the starting node. Okay, then while the open set dot count is higher than 0, then we're going to need the current node and start checking with the open set. Okay, with the first entry of your open set. Then open set on each node that we have onto our open set, we're going to look for the open set I of the fcost if it's lower than the current node dot fcost, or the open set I dot fcost is equals as the current node dot fcost and open set I, the heuristic cost is lower than the current node dot heuristic cost. Then that means if the current node is the same as the open set, or if it's actually not the same as the open set, then the current node is going to be your open set I. Okay, you're basically checking the cost that you calculated to get back onto to find your current node. Then we're going to remove the current node. Okay, if current node equals your target node, then that means on your result you're pretty much done, and we want to do retrace. We do not have the method yet. Okay, so let's comment this entire line out, and we're going to do a break on our while. Otherwise, for each node, let's say n, or just node, in get neighbors, which we do not have yet, for your current node, let's create this method. And let's also create the retrace path. Okay. So let's finish with the get neighbors above here. And since we have this now, this can be ready as well. And here, if the closed set doesn't contain the node we are currently looking at, then we need to calculate the move cost, which is getting your current node g cost, running it via a method we call getDistance, which we haven't created yet, from your current node and this node. And let's implement this action. Let's generate it. Okay, before we move it to this, and this returns a retrace path, list nodes, retrace path. And if the move cost is lower than your node's g cost, or the open set does not contain the node, then node.gCost equals your move cost. Then your heuristic cost is get distance from node to your target node, and node.parent node equals your current node. And if it's not already on the open set, open set.add your node. Okay, down here we simply need, outside of the while loop, we're simply going to return a result. Okay, so let's create all of these methods now and populate them. Let's start with the get distance, then the retrace path, and let's leave the get neighbors at last, because we are going to make a lot of changes, a lot of things. We're going to add a lot of things in there. So for get neighbors, we first need to find the distance x, not get distance, get neighbors. Let's rename this to node 1 and node 2. and we have this as a float, but yeah, for whatever reason I have this as an integer. Anyway, so let's say float distance x. Let's see, because we have vector2 integers or vector3 integers, there is already a built-in method to find us a distance from node 1, node 2, but I don't know the result. I don't think it's going to be exactly what we need. So I'm going to say mathf.abs b1 dot node 1 dot grid position dot x minus b2 node 2 grid position dot x. Okay, let's duplicate this 2 times for y, z, and then y, and y, and then z and z. Then if distance x is greater than the distance z, we're going to say return 14 multiplied by distance z, and actually let me reply. And actually, let's go and look on what I had. I want to get the exact values I had on my A star for Unity. We have on my GitHub actually. So let's go to scripts. I guess I could have just used the same scripts, and just edit what I didn't want. So get neighbors, let's find the get distance, and here it is. I want to have this too. Okay, because it also has the calculations for the y, which we didn't have. No, okay, we did have them. Well, anyway, let's copy this entirely. I think I didn't do much. Yeah, it doesn't do much of a change. Okay, so this will get you the distance. So there's that. Then back to the how we get distance. We need the retrace path. Okay, retrace path is simple. We have our path, current node, then will be the to node, or let's rename that to target. And while the current node is not equals the from block, or let's rename this as well to start, then p.add current node, and current node equals current node dot parent node, and simply return the path, and there is the retrace path. Now get neighbors. Here's where things are going to start getting interesting. Well, sort of. We'll do this, we'll see this in a bit. So on get neighbors, we're going to of course return a list of nodes for our result, and return we're going to nest all of our values. So we're going to be going from -1 to well, we want to look on all axes at this point because we have 3D A star. We are in space, so it makes sense to, you know, look on every angle we can. So this will be -1. This is terrible. Z, say 1, but we want to start from -1 and z equals to 1. Okay, awesome. So let's create this as a vector3 integer target position. We start with vector3.0, then x will be x, y will be y, and z will be z, but plus node dot grid position dot x, node dot grid position dot y, plus node dot grid position dot z. Okay, then we need to get the neighbor. So get from grid manager, get node target position. If this is the same one, so maybe let's do it like this. So if x is 0 and y is 0 and z is 0, just continue. So we have our node, and if the neighbor is not null now, we're going to get the neighbor. So we're going to start searching everything inside the neighbor to see if we can actually move there. Okay, get neighbor, the search position from where we search from, or let's say from, and actually let's see, search position, the second one is the current node and where we are searching for. Okay, so this will be search position and node will be your current node. Okay, so neighbor not equals null, node path target, get neighbor. The first one will be your search position, so let's maybe rename this to search position, and this one now will be your current node, which that is the block we passed from above. So let's just add n. Maybe rename this to current node, I guess. Okay, and if the path target doesn't return null, we add that onto the result. So in here we are free to do anything we like. Okay, which means, let's see. Well, okay, for now, let's try and just return the search position no matter what. So we have the search position. Okay, I'm going to go onto my mouse operations and get mouse button down. Instead of doing everything we are doing here for building, just for testing, I'm going to put all of this inside its own method. Okay, and I'm going to add public bool. Actually, okay, we don't need to be building right now. We're actually going to need it later. Public bool and say build mode. Okay, if build mode, call that method, otherwise void unit Pathfinder. Now, because I don't really care that much about it right now, I'm going to say public grid object unit, okay, and I'm going to say, well, we do need the detect node and handle floors, so let's move both of them up here. So if current node is not null, then if input get mouse button down, we're going to do, we're going to request a pathfind for our unit, a grid object, and let's see. Okay, we are going to need a callback, however, and that callback will be void. Okay, let's call it Pathfinder callback. We are going to change this later because we're going to add the framework we had on the original colony sim. Node unit. Oops, not grid, not unit, grid object. Okay, and you know what? I'm just going to make a method public void load path to this, which is just going to get you, once we add the generic, it's just going to get you a list of nodes and you have your path. We're going to fix this in a bit. Look, dude, if you are going to talk in English, so the rest can understand and reply to you, because I really don't care whatever you're saying there. Okay, then I'm just simply not going to bother, or maybe block you. It's up to you. So we have a load path, and let's go back to our mouse operations, and then we've got a node. Okay, then let's do grid manager. Actually, not grid manager. We need, okay, let's use the Pathfinder, and let's do the singleton here. Let's do public static Pathfinder master singleton equals this. Okay, then mouse operation, Pathfinder master singleton request pathfind from the node the grid object is currently in. So let's say unit, or what we have, unit dot current node, the current node you are in. Now we have to pass the unit again. Obviously this is kind of pointless, but you can calculate, the unit can be from a different place and you can calculate this from a different node. Okay, that can play to the role, maybe if you want teleport or stuff like that. Okay, it has some value to this. We are going to see it later. So we need to find our grid manager. We can do this via singleton, and we have the callback, which is this Pathfinder callback. Okay, awesome. Now, if this unit is actually though calculating path, we don't want to be running that again, so is calculating path. We don't want to run a lot of this logic, so let's go down here and do if unit dot is calculating path, return, otherwise unit dot is calculating path equals true. Then on to our mouse operations. For this I'm just going to do unit load path, and there's a reason why I'm not just doing this right on the callback, because I'm going to move this later into a unit manager and stuff like that. Okay, now I just want to see this like it's actually working. Okay, so if is calculating path, is going to set this to false. We're going to store our path here, current path, and then let's do current path equals path. Now, since we do have a path, I'm going to do update. Let's do a public bool has path. If you do not have the path, simply return. Obviously, we're going to write this much more cleaner later. So, let's see. Actually, let me go and copy what we had before, because why writing it again? There's no point. Let's see. Yeah, okay. So we have our path index, we have our path t, we have the current or the from node, we have the to node, and we're going to need a path, a speed, float speed, let's say 5. We're going to need an actual speed, okay. Then we're going to need is init. So loading the path will say is init equals false. Path t is going to be 0. Path index is going to be 0 as well. So if not is init, then current or 2 will be current path index, okay. However, if path index dot or path index is higher than the current path dot count -1, then has path will be false, and simply return for this frame. We don't want to do anything else. Okay, we have our 2. Our from will be your current node. Then we need to find the distance, our real distance this time, on our vector3 dot distance from dot okay, from come on, let me think. From dot wall position, okay, to dot wall position, okay. Then speed will be speed actual will be speed by distance, so you're moving the same position, okay. Then your t, your path t, actually path t will be 1 minus your previous path t. So if the path t is 1, it's going to start at 0, okay. Otherwise, because we want to keep moving, it's going to remain the same, okay. And of course is init equals true. I think this too is going to work. So while this is moving, we're going to need our path t. We're going to be adding speed actual by time dot delta time. If path t is greater than 1, is init equals false. Path index plus plus. If path index is greater than the path count or current path dot count -1, then you finished your moving to that node. Okay, we're going to do a lot of things later here, but right now I'm just going to say path equals 1, has path equals false. Okay, else just continue, I guess. So vector 3, target position, vector 3 dot lerp from dot wall position to dot wall position, and we forgot one more thing. Okay, from our current node is now actually the to node, and this needs to go via path t. So transfer dot position, target position, and there we are. How can you contact me on Facebook or Instagram? You should not contact me either on Facebook or Instagram. There is ways to contact me. Use Discord or Twitter or whatever, or actually just use Discord. The community there is there to help you. So, okay, we have all of that going. Now, we do need, however, on start to assign the current node on the first frame we are in. Only problem that can arise is if the grid is actually made on start. We do this on awake, so we are good. Okay. We will then have a node to actually place this on. So because we're doing this on real easy, on start, this will work. So current node will be, actually it shouldn't be like this. Let's find a node, and let's do grid manager, singleton, get node from transform.position, and if this node is not null, if it is null, you have a problem, go fix it. Current node equals node. Then your transform.position will be the one you have on your wall position. So I'm going to remove this because if the current node is missing, you're going to need to fix it either way. Otherwise, we're going to have problems. So that's going to work. Okay, so technically this should work technically, unless we forgot something. We're going to see. So we have all of this. Let's go under mouse operations. And let's see. Unit Pathfinder, current node. Okay. Let's go and try it actually. Now I'm going to set this guy right onto the center, so that's going to make him be at, let's see, that's going to make him be at least on the far edge node. We'll see. Yeah, okay, we didn't get an error, so that means he is. And I'm going to click, and we get the error because we do not have Pathfinder master. Let's add this here. Okay, let's see what else. Pathfinder master. If we're getting this as a null, it's here. We know the Pathfinder master exists because we have it as a singleton and we just added it. The current node, even if it's null, is not going to be bothered in here. The unit is null. The grid manager singleton, we know it's not null, so it's the unit.current node. And true enough, we forgot to add it here. And of course, we also forgot to add the grid object to this. Here we go. And then drag that and add it into your grid object. Awesome. So let's click and nothing happens. Okay, so let's start debugging. We know that it at least comes to this. We know that this adds the path job, Pathfinder job, job is done. Find path. Find path actual. Yeah, we should start looking in here then. So let's go and add. Do we add everything? Hopefully we did. Okay, let's add a breakpoint here, attach it to Unity, and let's continue. I think we have a lot of time just yet. Let's see. Oh, we are in about an hour. Awesome. Time flies. Where your space? Okay, so I'm going to click. We are here and we start calculating. Get node. Yeah, okay. This will just continue to work. We have a lot of values that we don't actually need. So I think we should add maybe inside the callback the calls, but because this is using because we have callbacks to this, I don't know if it's going to work because it's now on a different thread. We'll see. It does come here. Okay. Then let's step into. Yeah, we never load the path. Oh no, we do load the path. We never tick the hash path. Set that to true and minimize. Let's hit play. I think his left hand is bigger than his right hand. Okay, he starts moving. He kind of teleported. He kind of keeps moving. So that's weird. Oh. And I think we forgot retrace. Retrace path, we forgot to reverse it actually. And the reason why I did forgot it is because on the colony sim I was actually doing it a step afterwards. So let's do reverse. Okay, here he goes. Okay. If we remove the fact that he jumps the first point, it's okay. I don't think I know why he jumps the first point. What did I miss? Maybe this is kind of wrong. Path T should be 1. Let's see what we had the other way, or the other one. Yeah, we have the opposite way. And this can be path T0, although we are setting it here as well. So now this can just stay 1. Okay, that should probably do it. Okay, let him come into view. Let's click. Okay, now, thing is, if I go up and down, you're not really going to be seeing much of a difference. But if I start going up and down, he's also able to move from one point to the other. So how do we test this? Really easy. First of all, let's go and create a method onto our grid manager. that is going to return us the midpoint, okay, the mid node. So public node get mid node, and that will be return get node grid size dot x subdivide by 2, grid size dot y subdivide by 2, grid size dot z subdivide by 2. Shocking, I know. But actually, hold on. I have a cunning plan. So, yeah, I wanted to do that. So, let's see, on our grid object, let's put him right on the center on start. Get mid node. We don't need any of this. Okay, so we can actually see him. So, now, onto our mouse operations. Let's say, whenever we are pressing if key code space, and that's not how you do it. If input get key down key code space, okay, build mode will be the opposite of your build mode. Let's also write a debug.log for saying build mode is plus build mode. Okay, just so that we know what we're actually doing. Just not here if I'm going to be building or not. Let this compile. So, hit play. Let's enable build mode. Yeah, actually, kind of did brain fart there. We need to set, whenever we are building now a node, we're going to say if it's walkable or not. And it's going to start true by default. Then on build manager, whenever we are actually building something, so here, for example, we're going to be saying, okay, this also controls, this knows that you are building inside the node. Okay, so we can say maybe is walkable equals false. Of course, this raises a different question, that moving in space while moving inside your base, it's a whole different story. But it's something we're going to see on a much later date, because I have a cunning plan. So, yeah, I actually want to see if you get the image, and you do. Awesome. And yeah, on the your Pathfinder then, instead of searching for your search position, we're going to say if search position is walkable, return the search position. Okay, otherwise return null. Okay, that's basically the most simplest A star you can have. Is it walkable? You can walk on the node. Is it not walkable? You cannot walk on the node. The only problem now that exists is if I build on top of him, he's not going to be able to walk. He's going to have problems starting. Okay, so the other problem that exists is that he will be able to go either on top or below. So let's say I get out of build mode and say I click him to go there. You can see he goes one space below. We cannot actually see him, but he goes one space below to move around it. Okay, so if I want him to skip an entire section, I will have to go to get out of to go again in build mode, and then I will have to build one down on the first floor, on the second floor, and on the third floor, because that's basically covering your entire grid. So now if I click him to go here, he can't go above or below, and yeah, okay, he can't go anywhere. Huh. Let's see. Even though you're not calculating... Oh, we are in build mode, I guess. Okay, he can't go around. He's calculating the path. Now it's taking more, however, because he is looking up and down. Interesting. It actually didn't work. It didn't work because I think it gives priority going up and down. So we should change the priority to be I think we should change the priority to first look left and right. Or we might have these positions wrong. Like, yeah, I think this position might be wrong. This might be either wrong as well. And from what I can see, he's calculating forever, which means goes through the entire grid right now, which is something we don't want. Keep that in mind. Yeah, I think this is a problematic area. So let's move that, and let's start with Pathfinder Master, and let's first of all check if target node dot is not walkable, then return. Okay, that should eliminate a few things. And actually, let's say target node not walkable, just so that we know that it's actually doing this. Okay, save that, minimize, let's move, let's hit play. Let's set build mode, let's build it. Oops, yeah, because he's everywhere now on a non-walkable node, he wasn't going to be able to move. So let's move him aside, let's build here, let's build down, and let's build up, and let's tell him to go here. And after we get out of build mode, so he's going to go around the nodes, and that works. Okay, now one thing that is wrong with him is that his pivot point is right on the center, which means he kind of looks offsetted. So I'm just going to move this on his legs. Okay, then move. Now it looks a little bit better. So if I build next to him like this, well, of course he's always going to be looking offsetted because these are too tiny. We'll fix it later, I don't really care. The Pathfinder for this is pretty specific, I want to say. Okay, so let's make this guy, depending on which floor he is, let's make him change his colors. But first, we kind of need to know on our mouse operations or on the grid manager, we kind of need to know which floor we're currently in, floor parents, and let's see how do we do this. We don't. So let's do a public static integer current floor. Okay, then current floor equals y, the target floor we want to go in. So on to our grid object. Whenever we're changing the current node, we're going to be doing it via public void change current node to node target node, and then current node equals target node. Change current node, then it's going to be happening here. We need a reference to the sprite renderer. Okay, then we need to know if current node dot grid position dot y is equals, actually let's say integer player floor grid manager current floor. So if grid position equals the player floor, then sprite renderer dot color will be color dot white. Else, if okay, let's say my floor, let's cut all of that. Okay, paste it. My floor, and if my floor is lower than the player floor, else you're hired. So let's do, yeah, it's kinda best if we do custom colors. So let's get the same values we have from the grid manager. So yeah, okay, this can just stay white. So grid manager singleton, let's see, where do we have the color? Yeah, it's above and below, so let's give that on below and let's give that as above. Okay, but this will also have a dirty flag for this should be running whenever there is, yeah, okay. So we need to do a public void handle floor color and do all of this in here, because whenever we are changing a color, we should be changing for each grid object, we should be changing the color again because it's a variable that the player is controlling. Okay. So, any questions? Anything? Now, let's go then at here and then say list grid objects. And on the grid object, on start, we should probably do a register. Okay, we are going to change this in the future once we create a unit manager and so on. So it's okay. Now, because we're going to be using the grid manager, let's store that. Okay, then register this object. Okay, then grid manager down to the floor. We're simply going to be going through all of them for each grid object. Geo in grid objects, geo.handle floor color. Store, save, okay, then he'll play. So we are on the same node, and what do we have? Oh yeah, forgot the sprite renderer. Unit, drag and drop that, awesome, hit play. Okay, we are on the same node, we are below and he is below us. That's kind of the same thing. So let's go up, and yeah, we weren't building actually. let's go down. Let's build. Okay, then let's get out of build mode and let's tell him to go down. Yeah, okay, let's build on the first node, on the first level, and let's tell him to come down here. And you see, whenever he's changing his color, he is going onto a different level. So if he's above this path, above the base, and we go down, he's actually down there. And we can tell him to go and move there, and you will see he's going, and depending on the floor he's actually looking up and down and so on and so on. So that's, yeah, that's the Pathfinder, the base of the Pathfinder, which is now in 3D space. However, clicking now into a node that belongs inside the base, and the base itself should of course have some additional things. It should of course have doors, so your players can get inside doors and so on and so on. Okay, now things are going to start getting a little bit complicated, and depending on if you are going inside a node that is inside the base, we're going to treat differently than going from the outside world, okay, from just moving into space. Yeah, okay, let me think. First of all, you know what we can do? We can just make this guy be slightly smaller than your base. And maybe even more smaller. Let's go by 20. 8 times smaller. So he's actually looking sort of like the base. Yeah, okay. Good enough, I guess. Okay, now we have some issues with this, I guess. And I think it's because let's see. Yeah, and yeah, no. The issues, I think it's with this. Because if we, yeah, because the pivot is right there, it should be a little bit more upwards. Let's see, set this to custom. Yeah, this will be 15, but let's say 2 pixels, or let's do 3 pixels up. Same with all of them actually. And set this to custom, and let's say 3 pixels up. Okay, hit apply. And because they are going to be sitting on the same position, we should probably, yeah, we might have some clipping issues. We'll see what we're going to do about that later. I don't really care that much. Okay, looks good enough, sort of. I think something is offsetted. Damn it. Yeah, we didn't change the, it only changed, what? It only changed one pivot. Didn't change all of them. What? 0.5. Oh, it's also changed this from pixels to, god damn it. Pixels 30. Pixels 30. 30. 3, not 30. Okay, let's hope that this will keep its values. Okay, it did. Okay, let's hit play. Now it will be looking good. Any questions or whatever? Okay, now there is some clipping issues because it should be higher order in layer, but it still kind of works, so it's okay. And maybe we can make the pivot even higher. slightly. And actually, you know what? Maybe we should set it to be in the center. So let's say 5, 6. Let's do 6 pixels. Okay, hit apply. Yeah, that looks much better. Okay, so back to the Pathfinder. Now we're getting into the real meat of it. But first, we kind of need to know where we have, let's see, by rows, select file, paste Sprite, import. And it doesn't actually work this way, damn it. Oh, and I didn't actually save it. And I think we need by columns, and we have X is 4. No, it's not going to work. And let's see. Import base sprite. We have 4 by 30 pixels. 30. Yeah. By 30. Yeah. Intel, what? Oh, come on. Well, okay, at least this works. So we could create frame 2 and just walk on to this. Let's add some color. Or let's just delete something, I guess. And let's say this is a door, but I'm going to just add a color so that it's distinct. Okay, whatever. We have our 2 colors. I'm going to export this again. We're not going to use this and this, of course. Let's change the name. Let's change this to doors, not the band. So here we are. Let's change this to Sprite. None. Point. Multiple. I think this is 12. Apply. Sprited. Oops. Yeah, okay. Oh, we did export everything. Oh, anyway. Grid by cell count, and I think it's going to be 8. Pivot, just going to set custom at 15 and 3. Slice. Let's see. Yeah. Damn it. Slice, pivot. Look at this shit. Incredible. They don't even have the pivot unit mode. Okay, and I think it's not. Let's see what we had to this. It's 6 pixels, not 3. So 15 by 6. 15 by 6 again. Okay, and hit apply. So we have our 2 doors, but the question is, how do we build the doors now? Anyway, And yeah, now this is going to take some time. Don't know if it's just going to take 1.5 hours, but I'm going to keep the stream max at 3 hours. Okay. If we do not make it, then it's going to have to be on the next part. So whenever we are making a build manager, we are going to be making whenever we are creating a node, actually we are going to not a node. Whenever we are building a node distance, that node distance is going to belong into a building. Inside that building, of course, it's going to hold nodes. Inside of any of those nodes, some nodes will be taken as door nodes. A door node is a node that it's an actual entry point from one pathfinding grid to a different pathfinding grid. Okay, so how do we do this mess? We're going to do a new class which we're going to call building. Space. Let's delete all of that. It doesn't need to be mono behavior. Let's add the bracket. And then in here we're going to need a list of all the nodes that actually exist inside our building, included nodes, or yeah, okay, let's say nodes. And we need a public list of nodes, of entry nodes. Okay, so whenever we are creating a building, we need to have at least one node. Okay, so nodes.add first node and nothing else, at least for now. Then on our build manager, whenever we are building a node, we are going to be creating buildings. Because we are using the square, it's easy to just get the entire lines we get from this and return us those nodes. So let's say build line of nodes. Okay, get node. So build that node should be returning back a node. Return null. Return null. And down here it should be returning you your node. But the problem is this build of node could be returning you back. No, this updates the node, so you don't have to worry about that. And this is what actually returns you the node. Okay, so we're going to say node return value or redval. And this is still going to be null, so return it. And once you've done all of this just checks, if we know it's going to update, this just checks what is going to be updating. So return value can be the node you are passing in, and down here just do return value. Okay, then if you are calling this from in here, we're going to also have a list of nodes for return value. And we're going to be saving that node return node. Okay, and if it's not null, yeah, that's kind of horrible what I'm doing right now, and actually how I am doing this, because I'm still getting the node. I could just return a bool to this. Yeah, okay, let's do it like that. Let's do it with a bool. and let's say false, bool equals false, or return value, okay. And then down here set that to true and return the return value, okay. So if build that node, return value rn, then if return value dot add node. Yeah, I don't actually want to do that though. Return the node in and out parameter because we already have the node, so why bother? Okay, so we have the return value, and which means it's going to be adding all of that. And finally, let's change this into a node, list of nodes. Return the return value, and this will be return null. Okay. Oops. Yeah, that's kind of pointless. We were doing this. Damn it. That's more important actually, because this is the one we are actually using, because it's building in a field square. But anyway, okay, we have all of it now. Doesn't matter. So this node, if node, if build a node. Oh, come on. Return value, which we do not have right now, but let's add it either way. Let us say return null because it's faster to check for null rather than the count. Okay, so build field square, and this is okay. This is inside the build manager, so technically we just need to have this can stay a void. Okay. We don't really need a return value then. Oops. We need a list of nodes. List of nodes. Okay, we don't need to return that. And then all of these nodes, we're going to be creating a new building. So we're going to be saying, we're going to include the from node. So building equals new building. Okay, maybe it's stupid to have the first node in the constructor. So let's ignore that. Building, then building dot nodes, add range, list of nodes. Okay, so now all of these nodes are inside inside a list, inside a building. Okay, so let's make it. If you right click on build mode, you are actually building a door, and just a door. But let's make it so that you actually have to have a door or a node to actually use it. Can I explain why in my code I prefer using the tick function instead of Unity's fixed update? Because you do not control either fixed update or anything. You only control tick. Okay. Basically update, fixed update or whatever, it's just a list that execute, And if you have two objects that have the update method or the start method or whatever, they run at the same time. Okay. If you're using tick, you can control which tick comes first, which means you have more control. So if you are passing references around, you know that something runs first, and you have more control in the order. It's basically just a habit I have. Yeah. And you can always do your own update method. If you've seen my old AI series, which doesn't actually exist right now, it's unlisted, I had all the enemies run their behavior or their ticks not on the same frame. I spread out the entire process in different frames. Okay, so they wouldn't calculate what they have to do on every update because there wasn't a need for that. Okay, and that allowed me to have like more than, I don't even remember how many, but there were about 80 different agents and whatever. But that was specific logic for that. Okay, it wasn't just basic stuff. There were a few other things in it. And yeah, to tell you the truth, I haven't really come into, I don't have any other examples than that, but that's a really good case. But I like controlling when everything updates or not. Okay, and sometimes I don't really care, so just do it in an update. Anyway, and what I was saying then, yeah, okay, we have our build manager. This is useless, this can just return. And yeah, let's go on our mouse operation and let's say build node. Okay, let's do public void build door. Okay, we need the target node, and then we're going to say if node dot node distance is not equals null, then node dot node distance dot sprite renderer. Let's see, what do we have here? We have we just update the sprite right away, and we get the sprite from base sprites, which is the base build. So let's add door. You know what? I'm just going to add the door. I don't really care if it's east or west. We just want to indicate that a node is a door. We don't have the graphics for it right now, so you know, who cares? And this will be door base sprites dot door. Okay, obviously we can fix this later, so you know, whatever. Sprite, okay. Then we need to know which building this node distance belongs to. So not only we're going to do a node, we're going to store the building for this. So public building. Okay, it might have a building, it might not have a building, doesn't matter. Node distance then, and let's see. Actually, this entire approach it's kind of wrong. Yeah, I just think of a simplified way to doing this. So let's do that. We still need doors, obviously, but yeah, okay, it's not that. No, you know what? We'll keep the building. We're just not going to use it just yet. We're not going to be categorizing our list into nodes. We're going to work with directions. But here's the thing. Directions are going to move the allocation or the processing power into the Pathfinder. Okay. Into this method, basically. If we split it up into different grid positions, we are splitting it into organizing, which means we are looking into smaller into smaller Pathfinder operations because the grids are smaller there. So we kind of have to decide: are we going to organize it, or are we going to make it look or are we going to use directions? And you know what? Let's try the directions first. It is multi-threaded, and it's not even that much optimized just yet. It just has some simple optimization, which is of course multi-threading. And I think simple directions are going to work first. If we have problems, we can then start categorizing even further, but I think it's just going to be fine. So the first thing we're going to need is directions. Let's go and add a new class. Let's call this enums or node enum, or let's just call them enums, whatever. Let's delete all of this, and we're going to have a public enum directions. We have north, south, west, east. Here's the thing, we also have northwest, northeast, southwest, southeast, up, down, up, northwest, up, west, up, east, up, and so on and so on. Okay, that's a horror show. So let's simplify. We have north, south, west, east. Okay, and we're going to have up and down. And we're going to go with these directions only at first. Okay, so we need a method that's actually going to be taking a direction, and let's find it. Which means we should eliminate some of the values. So for example, if x equals 1, or if x not equal 0 and z not equal 0, continue. Okay, this automatically eliminates diagonal movement. Oops. Okay, and then if y not equal 0 and x not equal 0, or y not equal 0 and z not equal 0, continue. This now eliminated diagonal movement upwards and down. Okay, so we're only moving Manhattan. In this case, we're going to bring the diagonals for the same floor, we're going to bring them back. We're going to see how bad it is, and then we're going to worry about moving diagonally. Okay, so search position is workable. Okay, now we need a method that is going to return us a direction, get direction from the vector 3, from a vector 3. Let's add the directions. Return value is going to start as, let's start as north. Return R. Here's one thing though. We need to set and say what's the north position, what is the earth position. Okay, so here's the thing. Let's hit play. What? Okay, and let's build let's build a node here, or let's build it like this. So the distance or the difference between this and this is at 50, this one is at 50, and this one is at 51 on the Z. So Z, let's see, so Z1 increase, so yeah, okay, if on the Z you are on the 1, that means you are going north. Okay, let's go from that. So if dir.z is greater than 0, return north. If dir.z is lower than 0, return south. Now obviously this works simply because we are moving in Manhattan. It's going to get a little bit more complicated diagonally later. So if dir.x lower than 0, return, I'm going to guess it's west. So let's see. If I move this on 48, yeah, it's going to have to, damn it. Let's build. Oops, I built it a lot. I don't want that many. Okay, let's say 2. And if I move this at 44, yeah, 44 is going to be west, so that will be minus. And if direction.x is greater than 0, return direction.east. Let's add the brackets just so that we know what's happening. If direction.y is greater than 0, okay, that's easy, return directions.up. And if direction.y minus 0, return directions.down. All of them, but we're going to go with Manhattan first because it's much simpler to do it at this point. So vector 3 directions from on the search position dot wall position minus current node dot wall position, normalize all of that, normalize, and then get the directions equals get direction from dir. Now, not only we need to check if it's walkable or not, we need to check if that direction is walkable or not. So things are going to be slightly more complicated right now. Instead of checking which directions you can walk to, we're going to check which directions you can't walk on that node from. Okay, so let's create a list. Okay, humor me. Let's try this. Let's create a list of, or a hash set, because why not? Hash set for directions, unwalkable directions. Okay, then on your enum, and you know what? Instead of creating a hash set and reserving the memory inside the node, let's do this inside the node distance, because the node distance are getting built progressively, which means we're going to end up with less variables stored in your memory. Okay, so if on your Pathfinder well, we're going to treat it if something is not built in. So if, let's say, search position dot node distance is null, treat it as a walkable node, so return the search position. Okay, but if it is, build it, then we're going to check on the no distance which direction, if that direction is blocked or not. So let's say, yeah, we do have the directions, okay, and then we're going to say, okay, so we're going to say if search position dot no distance dot directions, unwalkable directions, contains the directions, yeah, let's rename this to walking direction. So if it's contained inside the walking direction, return null, you can't walk that. Otherwise, for now, let's say return the search position again. Okay, so now we are going to be building on our build manager. Okay. Now we should be adding directions to this, and which directions you can walk to and you cannot walk to. So wall everywhere basically means you can't walk through any direction. But first, let's eliminate up and down. Okay, obviously. So if you are in here and saying the return value is true, it is that you build a direction, then we're going to be going inside our no distance and dot no distance on our unwalkable directions, add up and down. But first we're going to check if they do exist. And I'm just going to check for up, because if up is inside, then that probably means down is also as well. There is going to be some special nodes that are going to allow us to move inside the base up and down. Okay, so if it does not contain the up and down, just add them. There goes for them. Now if on the walkable, let's see, if we are walking, if we add wall everywhere, then that means we need to add on all of them. So that would be north, south, east, west. Now let's encapsulate a few things, because we're going to be doing a lot of stuff. So we're going to be saying public void add a walkable direction, directions, if a walkable direction contains direction, simply return, otherwise unwalkable directions, add the direction. Okay, so back to our build manager. We can just replace this into and no distance, add a walkable direction, up, down. Let's copy that. Let's go here, and we have north, south, come on, east, and west. We do not have destroying base, any base units yet, so this should be fine. So if you're adding wall west, you definitely, you know what? If you're adding wall west, then we need to check if you have left and right. Yeah, no, that's, damn it. Okay, let's improvise. We shouldn't do it like this then. We should do, let's not do the directions like this. I think it's kinda ugly. this way. Okay, so building a node returns us an entire list of nodes. Okay, so now we have all of these nodes. Do we? No. Where was this? Build field square, build square. Okay, we do not have that. Yeah, okay, that's the one we're using. So we now have a return value for all of this. It's going to be building. Okay, so if we do for each node n in return value, well, we know we're going to add a walkable direction. We know we're going to add up and down. Okay, then we need to know to get left all the side nodes we're getting, which is not that much ideal, to be honest. Okay, let's think this wisely. Because we don't have to go. Yeah, okay, so here's what I'm going to do. No. Well, first of all, we can get this, we can add this in here, so you can eliminate this one. Now, if you are indeed going to add a node in here, you could say, let's bring this down here, this as well. You could say directions dot node. Actually, we can test this right now. You just won't be able to go up and down. You will be able to move from any other directions, but not just straight down, technically. So if we hit play and go on the final node and just add something large, not this way, let's go up, let's make him move up, and let's build. And I'm going to click now for him to come in here. He should target node not walkable, damn it. Yeah, we forgot we did this. Now we can delete it entirely because we are going in through. Yeah, forgot what I was going to say. Okay, let's go build mode. Yeah, okay, and now let's tell him to move. Now he should go on the edge, yeah, comes down, and you can see that he moves from direction to direction because he can go up and down inside this. He can go from any other direction, just not up and down just yet. So we need to find an optimized way to actually update all these nodes into being, into any directions that you might be able to move. So there's one easy way to do this. First, let's find the edge cases, which is if x is 0 or z is 0 or x equals mathf.abs difference x or z equals mathf.abs.difference z. Okay, there's one optimization we can do here. I'm going to write the method and write the optimization if you can see it. Write the optimization in the chat. So these are going to be added into a list. You have till I'm finished with this method to tell me the optimization. Otherwise, I'm just going to say it. We're going to be adding a list of edge nodes. Okay, if any of these nodes is on the edges, then that means we're going to add that onto the edges, okay? Then afterwards, well, okay, let's write the entire thing, then we're going to do that. Then for each node, or actually let's just say check directions for each nodes. So we can say void check direction for edge node, and just pass the node, and we also need to pass the grid manager. Okay, so we don't need this then, which means check direction for edge node, and else let's pass the grid manager as well, and continue if it's an edge node. Otherwise, treat it like it's a normal node, like you can walk from many directions. Okay, we're all going to add this. Then for this we're going to do for x minus 1 to less or equals than 1. Then for z one equals minus 1. Okay, node neighbor node get node dot grid position dot x plus x, node dot grid position dot y, node dot grid position dot z plus z. If neighbor node, okay, now that kinda begs the question. Okay, here's what we're going to do. Okay, so here's what I'm going to do. I'm going to say vector3 direction equals vector3 dot dir. Oh no, we're getting the direction from the Pathfinder, don't we? So let's move this outside. Yeah, I'm kind of trying to think in ways of optimizing this. So let's cut all of that. Let's go under Pathfinder master. Then I'm going to make this public static directions get direction. Okay, because we're going to be creating more instances of the Pathfinder and only have one instance of the Pathfinder master. That's my logic behind Pathfinder master dot get direction. Okay. And we were doing build manager, or what is it? Build manager, okay. Then we're going to be saying vector3.0. Actually, yeah, okay, we can nest this, because why not? dir.x equals x, dir.z equals z, dir.y equals node.y. Here's the thing, node.grid position.y actually. Here's the yeah, okay. If x equals 0 or not equal 0 and z not equal 0, continue. So it only gets the edge cases. If x equals 0 and z equals 0, continue. Okay. So with this we can get the direction now. Direction. Yeah, no, that's kind of stupid. So we can make this into a vector3 integer and vector3 integer, because we are going to need the neighbor node from the grid manager either way. So get node. Dir. Actually, no, this gives us a direction. Yeah, okay. This is the direction. So no, that was correct. Okay, then we kind of need to find the node position. So that will be x plus node dot x, grid position dot x, z, z, and z. Okay, so we need to get x, need grid position dot y, z. Okay, we need to get the direction now. So directions, dir Pathfinder master get direction dir. Okay. Oh, dir enum, I guess. Okay, so this is the direction for, we have the neighbor node. We need to check if neighbor node dot node instance not equals null. That means we need to find this there then. Otherwise, there's no point in doing that. Then that means for your own neighbor node instance dot add unwalkable direction, the direction enum. Okay. Actually, no. It's the opposite. If the node distance is null, that means it's outside of your world, outside of your level. So that means, yeah, so that means you have a wall there. If you do have a node distance, then that probably is from inside your level. So I think that's going to work fine. Okay, well, okay, let's try this then. I'm going to move. So since nobody asked, tell me the optimization we can do here, fine. I'm just going to write it, difference x, mathf.abs, difference x, and then difference z, difference z. Okay, because mathf.abs does some calculations, we can stop. Yeah, we only have to make them once, as you can see. Otherwise, why bother? So difference x, difference z. Okay, check direction then. Okay, okay. Yeah, so this will add all the edge cases. It will look if you are outside, and on the cases that you are indeed outside, it's just going to add your unwalkable direction. I think that this will work, which means when we are now building a door, we can say, well, we can do the same thing actually as with the grid as we did above. And okay, well, you know what, I'm just going to do on the node distance, I'm just going to simplify it. I'm going to say public void add door directions, and it's simply going to clear all of it and just add back up and down for now. Later we're going to add the rest. Let's just test this. Okay, so select that, and then on your build manager, on your build door, you have your node, you changing your sprite, then node distance dot add door direction. Then on our mouse operations, select that, and that's the build mode. Yeah, okay, inside build mode, copy this, get mouse button down but the right click, and instead of doing store node, let's do build or current node, and just the current node. We don't need anything else. Okay, path. Okay, on else it's not going to do anything. Clear that. Let's compile. Let's see how we are on time. We are 2 hours and 10 minutes. If you want to ask any questions, we are going to be on for about 40-50 minutes. But in about, yeah, I'm going to leave that last 10 minutes or 20 minutes, depending for questions, stuff like that. Just saying. Okay, so let's find our build manager. It's down here. We have our base sprites. Well, let's add this door or whatever. So I'm going to build now on the same level, and I'm going to tell him to get inside. Okay, we missed something. Huh. She's doing the zigzag because we do not allow him to move diagonally. We'll fix that later. Okay. I think he's only avoiding edge cases. And let's see. Okay, that's the edge cases, which is it shouldn't be that case because we have up and down on each of these. Check direction. Let's stay. Actually, no. Yeah, okay. Let's say debug log. Build. Let's see how many we're going to get. Okay. And we didn't get any. We didn't get any because all of them are edge nodes. Let's do like this, and we do get enough. We did get 12. Oops. Yeah, you can work on all of these cases. This edge doesn't work, so that means difference x -1. Now you shouldn't be able to work on those other cases as well. Let's see. Let it recompile. Where to let Unity? From the... Come on. Really easy. Where was it? The best place to learn Unity is actually, shockingly, doesn't actually exist anymore. Really great. Yeah, from the official site anyway. They have the basic tutorials there. They are pretty good. So, yeah, everyone pretty much learn from that. So you do not have to reinvent the wheel, fortunately. Anyway, so I'm building now, and he should also avoid, yeah, he does avoid the other edge cases as well. He does not avoid these edge cases now, which is kind of strange. Oh, he went below. Yeah, okay, that makes sense. And he now is going, what the So, because it gets a little bit weird to get multiple floors and try to make this. I'm going to set the grid size at 1, so we only have 1 floor. Okay, so we can debug this eventually. And technically, I should, yeah, I can visualize the path instead of doing it like this. Well, I'm going to say that he's definitely coming in from these directions. So, okay, let's say maybe it's this as well. X not equal 0, Z not equal 0. If direction or distance. Okay. We know this is working. Let's see if you can work inside now. Yeah, okay. You can walk inside. Can you walk outside? You cannot walk outside, okay? You cannot. Oh, yeah. We're kind of thinking. Are we thinking them wrong though? Yeah, okay. One thing that I think we're doing wrong is the direction should actually be opposite. Actually, I don't know. We'll see now. Okay. Fair enough. Okay, just to be faster with this, let's add, let's find it. Now, if we add a line renderer, we should, yeah, okay. No, we still should be moving, anyway, ignore that. Previous colony sim tutorial, well, that's gone now. I kind of lost interest to that, especially with that great scope. I might do some more in the future on that, but it's not really on my plans right now. So, maybe this was working fine before as well. Okay, we don't need this now. Let's do Pathfinder get direction. Okay. Let's see if we are actually updating this. So, on how many directions you do actually add this. Let's do debug.log. That's not how you write the debug.log. Let's do the enump. Let's bring it below. Add that. Play. Let's see. We have 30 positions on the west, south, north, east. That's weird. Kinda thinking how I can debug this. Okay. Since we can't add one or one fill square, which is kinda wrong, let's do difference. If difference is x and difference is z, instead of returning null, let's actually get the node and build also on the position you actually have. So from the no, we do have the node, so just say build from return null either way, and then on your from let's change this here. Okay, let's add that. Okay, so now we're going to be building on the same position we're in. Let's try. Yeah, we're not in build mode. Okay, so now we are building one node, which means he should not be able to walk inside the node from any direction. So I'm going to call check direction for edge node. I'm going to call this in here on your from node, okay, and then I'm going to check which directions we can get in or not. Okay, so basically it runs all the other directions, so it means you cannot walk inside those directions. And if I build on this, west, south, north, again west, south, north, west, south, north. Okay, that kinda works. Kinda works. Okay, yeah, oh yeah, I know what it is. So, my initial thought that check direction for edge node, my initial thought for this was actually correct. That we need to add this on a list and run it afterwards, so all of the nodes are updated. Node, edge nodes, new list, and then edge nodes dot add node, and then let's do a for loop. Edge nodes dot length dot count. Edge nodes dot add, not add, check direction for edge node, edge nodes I, and grid manager. Now, this does start to have a few other edge cases that what I did just now, building one node here and another node here, didn't actually update this node's direction, that you can walk from there as well. So we do need that as well. So going down here, check direction for this. Well, first of all, let's get the direction out of here. And let's say here. If node distance is not equals null, okay, dir enum. But if it's not null, we need to update this direction. So we're going to say node distance dot unwalkable directions remove, and the direction we need to get now is the opposite direction we have. So minus dir, and remove from that node this unwalkable direction. So he should be able to walk from both directions. Okay. build one here, build one here, build one here, and maybe build a door here, and let's switch to walking, and you can't walk from a... Oh, you can walk now. He can walk inside. There's a few things we are missing. I'm going to find them eventually. So let's build one of these, and let's build a door, and let's click inside. He goes straight in. Yeah, I have no clue what's actually happening here. You know what? Let's say whenever this guy is moving on grid object and it's changing the node, if input dot get key code dot s, if I press s, if I'm pressing s whenever he's changing his node, for each node n dot not node, yeah, for its direction d in target node dot node distance dot unwalkable directions. Can we run that? Yeah, okay. Debug.log d, and also say application is playing or is paused. What is paused? Yeah, I forgot. I think it's editor application. Editor application is, let's see, is that going to show? Yeah, editor application dot is post equals true, and you do need to include Unity editor. Okay, if I'm pressing the S, but if target node dot node instance is null, if it's not null, then run all of that. Okay. Does anyone have any questions or whatever? Let's save that. Hit play. Let's build something. Then I'm going to click, and I'm going to be holding S. So up, down, north. God damn it. Ooh. The direction we need is on the Pathfinder is actually the opposite one. So this one tells you that you can't go up and down, okay? You can't go north, but the direction this guy is going is now south. So that means on your Pathfinder here, the search position was correctly set the opposite way before. So that's okay. Let's switch that and let's see what's going to happen now. Okay, and voila, he's going. Huh. That's kind of weird. All of these directions are, yeah, all of these directions, I have no clue as to why this, but let's go moving. Let's keep moving. Okay, we can move inside the base. If you're trying to walk outside, you can walk from these cases, but you can't walk from these cases. And I think it has to do with the build manager. Yeah, I think it has to do with this. Hit play. Let's move all that. Let's see. Yeah, oops. Oh. Yeah. So we actually need both directions. On the Pathfinder. So this is the path, this is the direction. This is your walking direction, which checks for this. Then let's check for the opposite direction. Pathfinder master. Get direction, opposite direction. So now it doesn't actually matter to this. Or search position, node instance, unwalkable directions contains opposite. So let's try with that, with this. This is up and down, up and down. What the? Yeah, okay, we're missing something, which I don't know what it is. Like this shouldn't, or is the edge cases? I don't fucking know. So I don't suppose anyone has any idea about this. Oh, yeah. The search position must not include the walking direction, but the opposite, depending, because we have this, the opposite, must not be included on your current node instance. Okay, so let's do it like this. Okay, return null. Else if, or actually just say if current node distance not equals null, current node distance dot unwalkable directions contains the opposite. This needs to be an if. Then return null again. Otherwise, return the search position. Yeah, we're getting there. We're getting close. Let's see how we are on time. We are at 2 hours and 35 minutes, which is a lot. And I'm actually getting pretty tired, so, you know, Okay. Yeah, I think that he's doing whatever. So you know what? Let's say yeah, no, I can't find it. So let's pause this. At least the Pathfinder for now. I'm going to have to look at it offline, to be honest, because I'm really, or look at it when I'm not tired, because I'm kind of tired. So you know what? So for the last 25 minutes, how much we have? Let's you know, let's actually color this guy a little bit better. I'm going to add this down here. This can be down here. Now this doesn't look that great. So maybe let's add this same value. Okay, I think it's kind of better this way. Or let's do it like that. Give him some legs or something. Okay, he looks like he has big hands. This can be his bottoms. This can be something else or whatever. Now there need to be the same pixels. It would be really nice if you were asking questions in English, so everyone that's watching is actually going to be understanding what you're asking on the chat. Because most of my audience is not even from Greeks, so I'm not even going to cater for specifically in Greece, so you know, English. It's not hard. We had to learn them in high school actually. So let's keep like that. Let's maybe try one line here and delete this. It's not that bad. Yeah, I think it's making him slightly goofier. Maybe not. Let's add him some nipples because it's going to be funny. Let's make it more like that. Yeah, okay. Perfect. It's actually self-portrait. Anyway, okay. So this will be the base character, the empty one. We can use this on the showers or whatever. Let's create him with maybe some spacesuit. The spacesuit is going to be slightly bigger. So let's build the base like this. Okay, something like that. Let's find a darker shade now. Let's do the outline. It's gonna be outline here, here, and I forgot what we had here. And I think maybe we can delete that. Well, 3, 2, okay. Probably we should do that. The outline is on both edges, which doesn't make a lot of sense, but whatever. Not going to worry that much for that. Okay, let's go with this. Let's make him have something bulging from behind, not just in his pants. I like it, like all of a sudden you start talking with the chat. It's kind of funny. Why not speak Greek? Why will I speak Greek and target only the 5 people that create games in Greece when I can target the entire world? Doesn't make any sense. That's why. There's somehow we can lower the opacity in here, but why? How? Don't suppose anyone knows. Oh, here it is. So let's do. Well, let's make this slightly. What the fuck? It's going to replace that. So let's add. Oops. Let's make a new layer and let's add onto this. Okay. What's this? Whatever. Yeah, I don't know why the alpha is not working. RGB. Oh, no, it should be gray mask. No. RGB. Well, it should have been working, but it doesn't. So I don't know. Let's try this. Oh, here it is. So let's try this. Or actually, let's pick up this. No, it's terrible. How things are going? I have found your Sharp Accent Twitch channel. Well, you can also find the actual channel on YouTube. You'll find a lot of things there, trust me. And you can also visit the site, which is at the left side of the screen. Yeah, I actually don't know what you refer to. I'm new to Twitch. If I ask for help in Greek, will you not give it to me? Depends where you're going to ask. Okay, let's put in some highlights. Maybe it's too bright for a highlight. Yep. Okay, there's a basic astronaut. Oops. Let's go low. Let's give him a belt. Because why not? Okay, let's maybe give him maybe give him. No, that's too much. Yeah, it's not that bad. Let's maybe pick this up. I think we can select some more of it. Okay, move the jar slightly more. Maybe move it slightly down. That looks funny. Yes, I'm restreaming it. I think it's Sarpaxen. Let me see. Or, well, let me try and find it. Yeah. I'm dropping the chat, dropping the link on the chat. So, something like that. Yeah, good enough, I guess. Let's give some detail on the back, because why not? And actually, I would like to create something as a background. How do we do this then? How do we move the... Come on. Yeah, okay. Let's close this. Let's delete it. Let's delete from this frame. Just add a fill color or something, just so that we know what's happening. Okay, then open them up. Ah, come on. Okay, better. Yeah, okay. Let's add some details onto the back of his back gear or whatever. Let's add some highlight, or sort of a highlight, just to make it look like something. I'm going to remove that. Okay, that's good. That looks good enough. Let's make this a different color though. Let's maybe give him a front zip line. Let's bring this further down. Okay. Don't think I like that there is 3 lines here. Maybe we can give him this line, and I think we're missing an ear. Oh, it's the highlight that does that. So let's add one here. Let's add something else for highlight, or maybe even nothing. Oh, yeah, okay. Let's leave the highlight in. Doesn't matter. What? Oh, come on. Okay. Fine. Let's see. Maybe we can add something darker down here as well. Okay, good enough. Let's see how we are on time. Yeah, I'll be on for about 10 more minutes. Okay, it's going to be on my YouTube, the video. So you can watch, if you missed it, you can watch it here, there. You can also watch, I'm saying this for the new members, you can also watch a lot more stuff in my site, sarpaxen.com. A lot of series. Yeah, I've been doing this for about 5 to 6 years now, so lots of stuff to watch if you're new. Okay, so I'd like to let's try some lines. Let's try maybe something that looks like you know, like he's giving, it's making him breathe. Let's add this here. Let's maybe say do it like this. Yeah, it needs to be a different color, definitely a different color. So we can actually read. You can see from here. Yeah, okay. I say it's good enough. Let's maybe darker this part and this part. Kind of looks like a face hugger or whatever. Okay, let's try maybe moving the entire helmet. No. Okay, let's maybe try deleting this part. Yeah, I think it's slightly better. Or maybe not. What? Yeah, okay, good enough. I think maybe this looks better. Now let's give him some slightly quote-unquote shadows onto this, and we should be done. Maybe not. No, that's too noisy. Maybe this then. Or this. That just gets gray. Anyway. Okay, let's leave it like this actually. Screw it. Let's add some more highlights onto this. Or maybe let's get the highlight from here. And that should do it. Maybe it's too... Okay, maybe like that. Let's move that part. No, I think I like the retro look. No. Okay, let's go with this. Okay, slightly better. Let's delete this too. Let's do that. Yeah, okay, slightly better. Anyway, do we have any questions? I'll be on for about 5 more minutes. This will be our naked guy. This will be our suited guy that he can go out of space. We're going to have airlocks and so on and so on. You know what? Let's give him a gun as well. Let's make a version where he also has a gun. Because why not? Going to delete all of this. Then let's do gray. Let's bring this forward. Let's bring all of that low. Okay, then let's make this as a gun. And let's make this white for his hands. Let's say like this. Maybe like this, and then like that. Then let's delete this so that we can actually see what the hell we're doing. And maybe let's put it on top of is gone. Yeah, okay. So let's make white gloves, then like this, like this. I think this needs to get darker then. Yeah, let's do that below. Let's maybe take this, make it even darker. Do I have Facebook? Yes, I do have Facebook for personal use. So, I'm giving it to you. And actually, kind of want to stop using it altogether, to be honest, because it's garbage. But whatever. Let's give him, maybe let's give it a bad stock or whatever. Doesn't look too sci-fi for a gun, but whatever. It's retro warfare, not just space warfare. Let's make it look slightly curved. No, what am I? Okay, good enough. But you know, since this is space, let's give him some. Let's give it a little bit more depth. Let's make it like a bolter rifle or whatever. So let's maybe give it a line. Okay, it looks good enough. No. Okay, but I'm going to change his hands to look white, just so they actually have some coherency with this. And maybe add this entirely blank. This as well. Oops. Now we're talking. Awesome. So, yeah, I think darker should be better for the most case. Let's try the bucket tool. Okay, good enough. Good enough, I guess. I don't understand. Yeah, I don't really like what's happening down here. So let's make it like kind of makes slightly more sense, I guess. But this needs to come up even more. Maybe just ignore this part entirely. Okay, maybe something like that. Maybe add the black spot down there, or maybe just extend the weapon. Okay, and let's make bright red. Now it does look like garbage. Nah, don't like it. Let's just leave it like that. Awesome. So, any questions? Not for pixel art, maybe for anything else? Anyway, why did we lose? We lost the highlight somewhere. Let's maybe add 1 point here and 1 down here. 1 point here, 1 down here. It's in a different place, but it's okay, I guess. Okay. How long for the rest of the project? Indefinitely. Until I'm get bored of this or until I finish it, but you know, if you follow any of my projects, they do tend to get huge, not just big. Just like this dong. And as you can see, I'm really mature. I don't like it. Maybe it's too big. So, that's it. I think we do not get... yeah, okay. We are at 3 hours. That's the mark. Next live stream from this is probably going to be... maybe Wednesday or Tuesday. Or maybe even tomorrow. I'll see. I want to do tomorrow some more assets for the turn-based series and some other stuff. So it might be tomorrow, and then it might be, well, inside the week. Join the Discord if you haven't. So I'm doing the announcements there for the rest, okay? So, yeah, and you will see, you can also follow me on Twitter to get the notification, but you get the notification right when I'm going live, so not really that useful. So, anyway, yeah, about that. As always, you know what to do. Like, subscribe, share it with your friends, family, acquaintances, or whoever. Then, if you like to see more stuff like this and so on, feel free to support me on Patreon so we can keep making all of this. And I'll see you on the next one. Either that will be a live stream or a recorded video. Well, we'll see. I'll see you when I see you. Okay, just one more. Well, goodbye. I have a cunning plan, and I'll see you on the next one. Toodle-doo.